If you bought a hammer in the last 5 years, there is a reasonable chance the head is already loose. If you bought a combination square at a big box store in the last decade, there is a reasonable chance it is no longer square. And if you bought a set of handsaws from a national brand in the last 3 years, the teeth are probably already dull enough that you are working twice as hard for half the result. You are not buying tools anymore. You are renting them at full purchase price every 2 to 4 years for the rest of your life. In this investigation, we are going to do something different. We are not here to expose what is broken. We are here to tell you exactly what still works. 5 specific tools with specific model numbers built to specific engineering standards that the modern tool industry has quietly abandoned. This is the list your grandfather would have given you if anyone had thought to ask him before the store stopped carrying what he used. Before we get to the list, you need to understand how we got here. Because these 5 tools do not exist in a vacuum. They exist in contrast to an industry that has spent 30 years systematically replacing every durable material with a cheaper substitute and calling it progress. The golden era of American hand tools ran roughly from 1970 to 1995. During that window, the major American manufacturers, Stanley, Disston, Estwing, Starrett, were competing on precision and durability. The materials they used were expensive. Drop-forged 4140 steel, cast iron machined to thousandths of an inch, tool steel blades hardened to resist decades of wear. These were not luxury specifications. They were standard. They were what a working tool required. Then globalization hit. Between 1998 and 2003, the major brands began shifting production offshore. Stanley moved the bulk of its hand tool manufacturing to China and Mexico. Craftsman, which Sears had built into a household name on the back of a lifetime warranty and American steel, began sourcing from contract factories in Ningbo and Guangdong. The Federal Trade Commission has documented this shift across multiple enforcement actions. They found that Stanley had failed its own Made in USA claims, resulting in a consent order in 1999 and a $200,000 to $5,000 civil penalty in 2006. For false Made in USA claims on mechanics tools. They call this process value engineering. We call it the great cheapening. The economics are straightforward. Switching from a forged steel hammer handle to a fiberglass over epoxy composite saves $2 to $4 per unit at scale. At 1 million hammers per year per brand, that is $2 to $4 million in additional margin every single year. Stanley Black & Decker has publicly stated long-term targets of 35 to 37% adjusted gross margins by 2028 through ongoing cost reduction initiatives. That language is in their own filings. They are not hiding it. They are announcing it to shareholders. The consequence for you is that the Consumer Product Safety Commission database shows multiple tool-related recalls from Stanley Black & Decker between 2015 and 2025, affecting millions of units, including a 2023 sledgehammer recall, alone covering more than 2 million units with head detachment as the hazard. Estwing, which we will discuss in a moment, has 0 recalls in that same period. 0. Not because they were lucky, because they never changed the design, but the corporate history is only half the problem. The materials themselves have been engineered to fail. And once you understand the specific substitutions they made, part by part, material by material, you will never look at a tool rack the same way again. Here's the list. The first tool is a hammer, specifically the Estwing E3-22S Supergrip 22 ounce. It costs between $40 and $50 at Home Depot or on Amazon. That price is going to sound either cheap or expensive depending on what you compare it to. So let us compare it to the right thing. The Estwing is one-piece drop-forged tool steel, head and handle, one continuous piece of metal. There is no joint. There is no epoxy bond. There is no over-molded fiberglass handle that separates from the head after 500 to 1,000 heavy strikes. There is nothing to fail, because there is no seam where failure can occur. The grip is a shock-absorbing nylon vinyl wrap. If it wears out in 40 years, you replace it for $10. Parts have been available since 1923, when Estwing's founder made the first one in Rockford, Illinois, where they are still made today. The modern alternative, a Craftsman fiberglass handled hammer at $25, has a steel head bonded to a fiberglass shaft with epoxy and a plastic overmold. Thermal cycling from summer heat to winter cold, combined with the vibration of repeated impact, degrades that epoxy bond. 2 to 4 years of heavy use, that is the documented failure timeline. The CPSC database shows the Craftsman hammer line with multiple recall events. The Estwing shows none. The only math that matters, $1 per year over 40 years for the Estwing versus $10 per year for a $25 hammer you replace every 2 to 3 years. Your grandfather bought one hammer, you are buying 15. The second tool is a square, specifically the LS Starrett 12-inch combination square, Model S6700. It runs between $150 and $200 direct from Starrett or through Woodcraft. That price will stop some of you. Stay with me. The Starrett is built in Athol, Massachusetts, where the company has operated since 1880. The blade is tool steel, precision ground, and etched to hold accuracy to within 1/1000th of an inch. The head is cast iron. There is no stamped aluminum. There is no plastic etching that rusts off and leaves you with a blank rule and a bent blade. Long-term users in the fine woodworking community have consistently documented Starrett squares holding accuracy for 50-plus years of regular shop use. The modern alternative is an Irwin combination square at $20. The blade is stamped aluminum. Stamped, not ground. Aluminum, not tool steel. It bends. Within 1 to 3 years of regular use, the blade is deflected enough that your right angles are no longer right angles, and you may not even notice until your joints stop closing. Every board you cut with a bad square compounds the error. The Irwin costs you $20 every 2 years. The Starrett costs you $3 per year over 50 years and is still worth 70% of its purchase price on eBay when you are done with it. Starrett has 0 recalls in the CPSC database. They have been building the same square for nearly 150 years because they have never needed to change it. The third tool is a hand plane, and this one requires some explanation for viewers who are not woodworkers, because the hand plane is the single most complex precision tool on this list, and the gap between a good one and a bad one is larger than any other tool category. We are recommending vintage Stanley bench planes, specifically the number 4 smoothing plane and number 5 jack plane, manufactured between 1950 and 1973. You will not find these new. You find them at estate sales, at flea markets, on eBay, and at antique stores, typically for between $30 and $120, depending on condition. That is the price point. Now, here is why. The vintage Stanley planes from that era have a cast iron body machined to within a few thousandths of an inch, a tool steel blade hardened and ground flat, and a Bailey-style adjustment mechanism that has mechanical memory, meaning you can set the depth, back it off, and return to the same setting without losing position. The sole is flat. Not approximately flat, actually flat, because it was machined flat by a company that understood what the tool was for. The modern equivalent, a plastic-bodied block plane from any big box brand, has an injection-molded polymer sole that chips, cracks, and distorts under the friction and pressure of regular use within 2 to 5 years. The blade is stamped, not ground. The adjustment mechanism has slot built into it because the tolerances on the castings are loose. Loose tolerances in a hand plane mean chatter. Chatter means a rough surface. A rough surface means you are doing with sandpaper what the plane was supposed to do, and taking 3 times as long to do it. The vintage Stanley path requires one thing from you: the ability to tune the tool when you acquire it. That means flattening the sole on a sheet of sandpaper on a flat surface, honing the blade on a whetstone, and setting the chip breaker. It takes one afternoon. Once it is done, that plane will outlast you. Parts, blades, chip breakers, frogs, adjustment wheels are available from vintage tool dealers and from specialty suppliers like Hawk Tools indefinitely. Because the Stanley design was standardized in the 1920s and has not changed. The fourth tool is a handsaw, and specifically, we are pointing you toward vintage Disston handsaws, manufactured before 1955, when the Disston family sold the company. 26-inch crosscut, 8 to 10 points per inch. You find these the same places you find the vintage planes: estate sales, flea markets, eBay, typically for $15 to $45. The Disston saws were hand-set and hand-filed at the factory. The teeth were shaped individually and set to a specific rake angle for cross-cutting or ripping. The steel was spring steel, flexible enough to resist kinking, hard enough to hold an edge through thousands of cuts. A Disston that has been properly sharpened by someone who knows what they are doing will outcut any modern handsaw on the market for straight-line work. The modern alternative is a big box impulse-hardened saw. The teeth on these saws are hardened by induction, a process that makes them very hard but also extremely brittle. They will stay sharp for a moderate period in clean, dry lumber. The moment you hit a nail, a knot, or green wood with elevated moisture content, the teeth snap. Not dull, snap. And because they are induction hardened, they cannot be resharpened with a standard file. The saw is finished. It goes in the trash. A $20 saw that lasts 18 months is not a bargain. It is a subscription service with worse terms than a streaming platform. The Disston can be resharpened indefinitely. A saw file costs $3. A sharpening guide costs $15. One afternoon of learning, there are excellent tutorials from the hand tool community on this, and you have a saw that is yours for life. The fifth tool is a bench vise. And here we are recommending the Wilton 6-inch Machinist's Vise, Model 600, manufactured in the United States in Wilton's Carpentersville, Illinois facility. It runs between $250 and $350. It is the most expensive tool on this list, and it is worth every cent. The Wilton 600 has a ductile iron body, precision machine jaws that are ground parallel to within 1/1000th of an inch, a precision machined swivel base, and an Acme thread steel screw. Every component in this vise was designed with a specific load requirement in mind, and every component was built to meet or exceed that requirement. The modern alternative is a zinc die-cast bench vise from Harbor Freight or any equivalent big box source. Zinc die casting is rated to approximately 40,000 pounds per square inch, and that is the advertised rating on the best zinc alloys, which these vices do not use. The real-world failure mode is this. You apply torque to hold a piece of steel for grinding or filing, and the base shears, not cracks, shears. The base of the vise separates from the mounting plate under a load that any working tradesman would consider routine. Harbor Freight has had multiple tool-related recalls affecting hundreds of thousands of units between 2015 and 2025, with vise failures among the documented hazard categories. Wilton is currently owned by JPW Industries, and that ownership history is worth noting. Some acquisitions destroy a brand. This one, based on available manufacturing data and continuing USA production in Carpentersville, has not. The Wilton 600 line has maintained its ductile iron construction and American assembly. That can change. Watch the manufacturing disclosures. But as of today, the Wilton is still the right answer. Now here is what happens when any of these tools eventually need attention. And this is where the comparison between the BIFL category and the disposable category is most stark. With the Estwing, you replace a $10 grip. With the Starrett, you replace a $40 blade. With the vintage Stanley plane, you buy a replacement blade from Hawk Tools for $35 and have a better blade than the original. With the Disston, you spend $3 on a saw file. With the Wilton, replacement jaw inserts are available directly from Wilton, and the Vise's screw and nut assembly is a standard Acme thread component that any machinist can replace. Compare that to the repair equation on the disposable alternatives. A Craftsman hammer with a separated head cannot be repaired. The fiberglass handle is molded to the head with epoxy. There is no replacement handle available at any price. The unit is landfill. A big box vise with a sheared zinc base has no replacement parts available. The manufacturer does not want to sell you a base. They want to sell you a new vise. A stamped aluminum square that is bent is not a square anymore. It is scrap. A consumer class action lawsuit against Stanley Black & Decker over deceptive product marketing settled for approximately $1.6 million, with no mandated design changes and no admission of wrongdoing. The tools that caused those failures are still on the shelf. The company made no changes. They want you to throw it away. They want you to buy another one. They want the replacement cycle to feel normal, because if it feels normal, you never question it. The 10-year total cost of ownership across all 5 categories tells the story with arithmetic the industry cannot spin. Budget tools in these 5 categories will cost you between $150 and $300 per tool type in replacements over a decade. The 5 tools on this list, purchased at full price today or sourced used for less, cost between $3 and $5 per year over their documented lifespans. At 20 years, the eBay resale value on a Starrett square is still 70% of purchase price. The resale value on a big box stamped square is 0. You are not shopping for tools. You're deciding between assets and consumables. Buy forged, not stamped. Buy cast iron, not zinc. Buy tool steel, not polymer. Buy American manufacturing with a documented history, not a warehouse in Ningbo with a compliance certificate. Buy the tool once. Maintain it. Pass it on. The 5 tools on this list are not rare. They are not expensive when measured against their actual lifespan. They are not difficult to find. What they require is that you stop shopping like a consumer and start thinking like a tradesman. A tradesman knows his tools. He knows what they are made of. He knows what they can take. He knows how to put an edge back on a blade that has given him 20 years of service. He does not replace tools. He maintains them. And at the end of his working life, those tools go to someone who will use them for another 20 years. That is not nostalgia. That is physics. Stop buying the marketing. Start buying the metallurgy. The tools that last are the ones built on the assumption that you are serious and that you will be back at the bench tomorrow.